Hello, I am Sujoy, and after a long time I am back with a new tutorial on operation research. I have already uploaded 45 videos on operation research covering almost all the topics in operation research, including transportation problem, assignment problems, linear programming problems or LPPs, network analysis, game theory and queuing theory. So if you want to watch any of my previous videos on operation research, link to all of my videos is given in the video description below. So I have already uploaded 2 videos on solving linear programming problems or LPPs. In that I told you how to solve a simplex problem of maximization type and how to convert a simplex problem into equivalent dual problem. So you can watch those videos to know more about the simplex method. And today we will talk about the simplex method minimization problem. So our question is minimize z or min z equals to 5x1 plus 9x2 plus 4x3 subjected to x1 plus x2 greater than equals to 3 and 3x1 plus x3 greater than equals to 6. So notice in the first inequality the x3 variable is missing and in the second inequality the x2 variable is missing. And x1, x2 and x3 are greater than equals to 0. They are called the non-negative constraints. That means their value is either 0 or greater than 0. That is non-negative. So let's proceed to the solution. The given problem is a minimization type problem. So we first need to convert it into a maximization type problem by changing sign of the objective function. These are our objective function minimize z equals to 5x1 plus 9x2 plus 4x3. So the change objective function is max z star or max z asterisk equals to minus of min z. The opposite of min z is max z star. So max z star equals to minus 5x1 minus 9x2 minus 4x3, and these are our equation number 1. So now to be able to solve the simplex problem, we also need to convert the inequalities into equations by introducing the surplus variables since they are of greater than equals to type. So as you can see, the constraints are of greater than equals to type. That means the left hand side is greater than the right hand side. That means we have to subtract something from the left hand side to balance it or to get the equals to sign. So the variables subtracted from the left hand side to get the equation sign are called the surplus variables. And remember, in the minimization type problem, the inequalities will be of greater than equals to sign. And in case of maximization type problem, the inequalities will be of less than equals to type. So if you want to know more about the maximization type problem, please do watch my previous video on simplex method. So otherwise we would have used the slack variables in case of less than equals to type. So max z star is equals to minus 5x1 minus 9x2 minus 4x3 plus 0 into x4 plus 0 into x5. Here the x4 and x5 are the surplus variables and they are multiplied with 0 since they don't have any effect on the objective function. They are just used to get the equals to sign. And subjected to x1 plus x2 plus 0 into x3 minus x4 plus 0 into x5 is equals to 3. These are our inequality number 1 where the x3 variable was missing, so we have multiplied it with 0 and we subtracted x4 from it, and x5 variable was also missing, so we just multiplied it with 0 and we got the equals to sign. So similarly for inequality number 2, it's 3x1 plus 0x2 plus x3 plus 0 into x4 minus x5 equals to 6. So we have just written the standard form where the variables which are missing are multiplied with 0 and we just subtracted x5 from it to get the equal to sign. And x1, x2, x3, x4 and x5 greater than equals to 0. They are called the non-negative constraints. And now we will write the matrix form where we will write all the coefficients. So the coefficient for the first inequality is 1 x1 or 1, 1 x2 or 1, 0, minus 1 and 0. That's written here 1, 1, 0, minus 1 and 0. Similarly, for inequality 2, 3, 0, 1, 0, minus 1. 3, 0, 1, 0 and minus 1. And they belong to 5 vectors a1, a2, a3, a4 and a5 into all the variables x1, x2, x3, x4 and x5 equals to the right hand side values, that is 3 and 6 written here. The vectors a2 and a3 are forming the identity matrix. Here you can see the vectors a2 and a3 are forming the identity matrix. An identity matrix is a matrix where the diagonal elements, the corner elements are all 1 and every other element are 0. So a2 and a3 are forming the identity matrix. So they are called the basic vectors and they will go into the basic vector column in our simplex table. So this is our simplex table. Let me introduce you to the simplex table. So in the simplex table, first we will make the structure and next in the first column we will write CB. CB stands for cost of basic. In the next column we will write capital B, that's equals to basic vectors. So our basic vectors were a2 and a3. So they are written here a2 and a3 and the cost for a2, above a2 the number is minus 9, that is written here. Similarly the cost for a3, that is the number above a3 is minus 4, that is written here. Our next column is capital XB or the basic variables. So for basic vector a2 the basic variable is x2, basic vector a3 the basic variable is x3. Next column is small b where the right hand side values 3 and 6 are written. Next we will write all the vectors a1, a2, a3, a4 and a5 and in that in the first row we will write all the values from the matrix 1, 1, 0, minus 1, 0, 1, 1, 0, minus 1, 0 and the next row we write the next row values from the matrix 3, 0, 1, 0, minus 1, 3, 0, 1, 0, minus 1 and in the CJ we will write the coefficients of the MaxJ star. So CJ is equals to coefficient of the MaxJ star. So that is minus 5, minus 9, minus 4, 0 and 0. Minus 5, minus 9, minus 4, 0 and 0. So let's start the calculation. First we will do multiply this number into this number plus this number into this number minus this number above. So let's do it. 1 into minus 9 is minus 9 plus 3 into minus 4 is minus 12. So minus 9 plus minus 12 is minus 21 and minus of minus 5. So minus of minus 5 is plus 5. So minus 21 plus 5 is equals to minus 16. That's written here. And for a2, this number into this number, that is 1 into minus 9 is minus 9 plus this number into this number, that is 0 into minus 4 is 0 minus this number. So minus 9 minus of minus 9, that's equals to 0 written here. Next for a3, 0 into minus 9 is 0, 1 into minus 4 is minus 4 minus of minus 4. So minus 4 minus of minus 4 is plus 4. So that's equals to 0 written here. And one trick for you, always remember for the basic vectors the below value or zj minus cj value will be 0. So our basic vectors were a2 and a3. So the zj minus cj value belong to them are 0. Next for a4, minus 1 into minus 9, that's plus 9 plus 0 into minus 4, that is 0 minus 0. So that is plus 9 written here. And for a5, it will be 0 into minus 9, that is 0 plus minus 1 into minus 4, that is plus 4 minus 0, that is plus 4 written here. And now after the calculation, you have to check the values in the zj minus cj row, that is this row. So after that, you have to look for the most negative number, that is minus 16. If there are more than one negative numbers, then look for the most negative number. Since we have only one negative number, so it's easy for us. So our most negative number is minus 16 and we will write an upward arrow next to this minus 16 column, that is A1 column. So this minus 16 belongs to this A1 column. So we can say A1 column will be our entering vector column and A1 will be our entering vector. Next we have to find out the exiting vector, that is the vector which will be replaced by the A1. For that we have to calculate the mean ratio, which is given by B divided by AI. So our AI is equals to A1. So the B value will be divided by all the numbers in the AI column. So 3 divided by 1 is 3 written here. Next V value is 6 divided by the A1 value, that is 3. So 6 divided by 3 is 2. And continue the operation if you have more rows in the simplex table, and you cannot do the division operation if the AI value or this value in this column is negative. And next find out the minimum value in the mean ratio column. That's why it's called mean or minimum. So the minimum value in between 2 and 3 is 2. So we'll write an exiting arrow next to this 2, and this 2 belong to the A3 vector. So our entering vector is A1 and the leaving vector is A3, and the pivot element is 3. The pivot element is the element which is intersected by the exiting vector and the entering vector, and that is covered by a square. And now before we proceed to our next simplex table, two more operations are needed. Number 1, first you have to make this pivot element 1, and next you have to make all the numbers above and below the pivot element 0. So first we will make this pivot element 1. So this is 3, we can make it 1 by dividing this by 3. And we have to do the same operation to all the numbers in this row. So 6 divided by 3 is 2, 3 divided by 3 is 1, 0 divided by 3 is 0, 1 divided by 3 is 1 by 3, and 0 divided by 3 is 0, and minus 1 divided by 3 is minus 1 by 3. Next this value is now 1 and the values are changed. Next we have to make this element 0 since this is above the pivot element. So to make this 1 0, by the help of this 1 we can subtract this value from this value. So we will do the operation with all the numbers in this row. So 1 minus 1 is 0, this is now 2, so 3 minus 2 is 1 here, this is 0, so 1 minus 0 is 0. This is now 1 by 3, so 0 minus 1 by 3 is minus 1 by 3, and this is 0, 0 subtracted from minus 1 is minus 1 as it is, and this is now minus 1 by 3, so 0 minus of minus 1 by 3, that is plus 1 by 3 at this position. So this is our next simplex table. All the values are changed. This is now 2, 1, 0, 1 by 3, 0, and minus 1 by 3. And this number above the pivot element is now 0, and all the values are changed accordingly. And now you can see the vector A3 is replaced by the A1, since the A1 was our entering vector and A3 was our exiting vector. And also the cost of basic is also changed. The value above A1 is minus 5, that is written here. And also the basic variable is changed, is now x1. And now we have to do the same operation. This number into this number, that is 0 into minus 9 is 0, plus this number to this number, that is 1 into minus 5 minus this number. So minus 5 minus of minus 5 is 0, that is written here. Next for A2, 1 into minus 9 is minus 9, plus 0 into minus 5, 0, minus of minus 9. So minus 9 and minus of minus 9, that is 0, written here. And as I mentioned earlier, the zj minus cj value for the basic vectors will be 0. So our basic vectors are A2 and A1, and the zj minus cj value corresponds to A2 and A1 are 0. So next for A3, minus 1 by 3 into minus 9 plus 1 by 3 into minus 5 minus of minus 4. So that's equals to 16 by 3. Next for A4, minus 1 into minus 9 plus 0 into minus 5 minus 0, that's equals to plus 9. And for A5, 1 by 3 into minus 9 plus minus 1 by 3 into minus 5 minus 0, that's equals to minus 4 by 3. And now we have to find out the most negative number, that is minus 4 by 3, and we write an upward arrow next to this column that belongs to A5 column. So A5 will be our entering vector. And next, to find out the exiting vector, we have to calculate the mean ratio. So that is given by B by AI, that is we have to divide all the numbers in B column by the corresponding numbers in A5 column or the entering vector column. So 1 divided by 1 by 3 is 3 written here, and 2 divided by minus 1 by 3. But as I mentioned earlier, this B number cannot be divided by the minus number or any minus element. So this division is not possible. So we'll write a simple dash here. So the division by minus value is not allowed. So we have only one value in mean ratio column. So that is 3, and that belongs to A2 vector. So our entering vector is A5 and leaving vector is A2, and the pivot element is 1 by 3. Pivot element is the element at the intersection of the entering and the exiting vector, and that is covered by a box. And now, as mentioned earlier, we have to make this element 1 and all the numbers above and below the pivot element 0. So first make this number 1. We can multiply this number by 3 to get a 1. So 1 by 3 into 3 is 3, that is 1 written here. Minus 1 into 3, that is minus 3 written here. Minus 1 by 3 into 3, that is minus 1 written here. 0 into 3 is 0 written here. And 1 into 3 is 3 written here. So this pivot element is now 1, and we have to make this number 0 with the help of this number. So this is 1. So we can divide this number or this 1 by 3 and add that to this minus 1 by 3. So 1 by 3 plus minus 1 by 3 is equals to 0. So first make this number 0. So if we add 1 by 3 or this number to this number, we'll get 0. So this number plus this number is 0. Minus 1 plus 0 is minus 1. Minus 1 by 3 plus 1 by 3 is 0. 1 plus 0 is 1. 0 plus 1 is 1. And 1 plus 2 is 3. And next, this exiting vector or A2 vector will be replaced by the entering vector A5. So that is written here. A2 is replaced by the A5 and the corresponding variable is X5. And the value above the A5 is 0, that is written here. This is the cost of basic value. So this is our third simplex table where the A2 vector is replaced by the A5 vector. Now let's start the calculation. This number into this number, that is 0 into 0, plus this number into this number, that is 1 into minus 5, minus of minus 5, that's equals to 0 written here. So for A2, 3 into 0 plus 1 into minus 5, minus of minus 9, that's equals to plus 4. So for A3, minus 1 into 0 plus 0 into minus 5, minus of minus 4, that's equals to plus 4. And for A4, minus 3 into 0 plus minus 1 into minus 5, minus 0, that's plus 5. And for A5, 1 into 0 plus 0 into minus 5, minus 0, that's equals to 0. So since all Zj minus Cj values are positive, the solution is optimal. And next we have to find out the values for A1, A2, A3, A4 and A5. And that we will get from the B column. So A5 is present in the table. So the value for A5 we will get from B column, that is plus 3. So A5 is equals to plus 3. And A1 is also present, and the value for A1 is plus 3. That is written here. and A2, A3 and A4 are not present in the simplex table. So their values will be taken as 0. So A2 equals to 0, A3 equals to 0 and A4 equals to 0. So next we will find out the max j star, that is our equation number 1. So the max j star is equals to minus 5x1 minus 9x2 minus 4x3, and by putting the values of x1, x2 and x3, that is minus 5 into plus 3 minus 9 into 0 minus 4 into 0, that's equals to minus 15. But according to our question, our objective function was mean z, so we need to find out the mean z. So the mean z we know equals to minus of max z star. So the mean z equals to minus of max z star, or minus of minus 15, that's equals to plus 15, and this is our required answer. So that's it for now. How was the video? Let me know in the comments below. I will upload more videos for you, so don't forget to subscribe to the channel, so that when I will upload my next video, you will get an email if you subscribe. And it takes a lot of effort and research to make a video like this. So if you appreciate my effort, please like and share the video. So thanks for watching. See you in my next video. And till then, stay connected by subscribing.